Hi class, this is me, Mr. Wee. So I'm going to go over another problem, is finding tangents for something that is horizontal. Like a, so let's see here. And what I mean by, so we're going to find tangents, oops, sorry. Finding tangents for horizontals. We're going to work on number 33 in your book for 2.4 and ask, at what point x, y is the tangent to f of x being x squared plus 4x minus 1 horizontal. At what point, so basically I'm asking, like, if we had a graph here, right? And I could take the tangent, right? I could take the slope, basically, these limits as h approaches 0, but at x equals what? See, the limit as h approaches 0, but this could be x equals, so if this was on a xy coordinate, right? This would be x equals like -2, this would be x equals 2. What we're trying to find out is at what point is it horizontal? The limit as h approaches 0, what is the x equal to? Again, it's nothing different with the limit of h is x equals 0, and we're trying to find what the x value is. But what we're really also trying to find out is, let's say that the limit of h approaches 0 at the point of x equals 2. Let's say the slope here, if we estimate it, that's like a +3, let's say. That looks pretty steep, okay? Let's look at this one. The slope at x equals 2, the actual slope, meaning the limit of h equals 0, I would say this is like a negative slope. This would be like -3. Here, I'm trying to find out where it's horizontal, and if you look at it, what slope value is that? That is a slope value that is equal to, so the limit of whatever this is, okay, whatever that is, we're trying to find out when it equals 0. At what x value does this whole thing equals 0? So let's find out how we would set that up. Your solutions manual I don't really like for this, so let's see how I do it. It's the same thing as what your solutions say, it's just I changed one term. So all you're going to do is this. We don't know what the x value is. Simple as that. We don't know what it is, so we're just going to leave it as f of x plus h minus f of x over h. Okay? And we're going to set this equal to 0. Realistically, we're trying to find out where equals 0. So let's figure this out, okay? F of x we do know, thankfully, is x squared plus 4x minus h, but you know what that means. Anywhere where there's x, I'm going to have to plug in x plus h. So it's going to look like this. The limit as h approaches 0 of x plus h squared. That already looks really ugly. So it's just a tedious problem. But if you know how to set it up and do it, it's not that bad. X minus h, or x plus h, I'm sorry. Let's see what else. You have to do -1, so that also stays the same. So this whole thing is f of x plus h minus f of x. So f of x is just x squared plus 4x, all in parentheses, -1, all over h. So let's see what that looks like. Again, let's expand this out. H approaches 0. This is going to be x plus h squared. So that's x plus h times x plus h. That's basically two binomials being multiplied to each other. Minus 4x minus 4h minus h minus x squared minus 4x plus 1. I distribute the negative value to each of those numbers here, okay? All over h. Let's rewrite this again, and let's kind of back up a second so you can see the math here. This looks like limit of h approaches 0 of x squared plus hx plus hx, so that's hx times hx plus h squared. So I expanded out this two binomials to one polynomial, okay, minus, let's see if I can combine like terms here. Let's see. Oh, you know what? I accidentally wrote that incorrectly. So that should be plus 4x plus h plus 4x plus 4h, okay? So this 4x and this 4x look like they're going to cancel out. And is there anything else? This one and this positive one are going to cancel out. So it looks like I have plus 4h minus x squared all over h. It looks like these will cancel out too. Always try to cancel out as much stuff as you can, okay? And then these two hx's are going to combine because they're like terms, so it's going to be 2hx plus h squared plus 4h all over h. And guess what? It looks like I can factor out an h out of all these guys, so we're left with, I think, this problem. The limit of h approaches 0. Let's factor out that h. So I have 2x plus h plus 4 all over h. This factors out now, okay, or cancels out now. And then now I have the limit as h approaches 0 of 2x plus h plus 4. I can now plug in h equals 0 into this equation, because if I try to do it up here, it would have given me an answer that is over 0, which would have ultimately given me infinity, which isn't a good real number. But now if I plug in h in here the way it looks, I will actually get a real answer, giving me 2x plus 4. Okay, and I asked you where the tangent is horizontal. This is basically figuring out tangent slopes, this limit of h approaches 0 of f of x plus h minus f of x over h. I have that now, and remember, this whole time I said set this whole thing equal to 0. So really, this whole thing was equal to 0, but we didn't do anything with that until the very end. Now all you have to do is find, remember I'm asking you at what x value is the limit as h approaches h equal to 0, the slope equal to 0. I just set this equal to 0 now, then I solve for x. I get 2x is equal to negative 4, divide both sides by 2. My final answer should be x equals negative 2. I don't know if you can see that, but that's a negative 2 in parentheses, okay? So that's where it is. So my graph is wrong. It should have been over here, okay, where the horizontal line should have been. I knew it was a parabola because anything with x squared in it, x squared plus 4x minus 1, the highest degree is just a square value, then that should be a parabola, okay? All right, guys, that's it. You guys have a wonderful day.